Here's the first sample test, problem number 3. A truck on a straight road starts from rest, accelerating at 2 meters per second squared until it reaches a speed of 20 meters per second. Then the truck travels for 20 seconds at constant speed until the brakes are applied, stopping the truck in a uniform manner in an additional 5 seconds. How long is the truck in motion? In this motion we have several intervals of constant acceleration. And so let's take a look at that. If we were to graph this as a velocity versus time graph, we would start off with no velocity, and under constant acceleration we would achieve finally a velocity of 20 meters per second. Do that for 20 seconds, and then we decelerate in a uniform way, a constant acceleration, until we finally come down to a velocity of 0 and we stop. So we know that this middle section has a time of 20 seconds and this final section has a time of 5 seconds. But this first leg, we really have 3 legs here. We have a first leg, a second leg, and a third leg. And in this first leg of this journey, what do we know? We know that we start from rest, so our initial velocity was 0. We know our acceleration is 2 meters per second squared. We know that our final velocity is going to be 20. We don't know our time yet, and we don't know our displacement. But we have enough information to find these things. We have 3 kinematic variables. And if we were looking for the 4th one, which is time, we would select those 4 variables there, and it looks like kinematic equation number 1. So final velocity equals initial velocity plus acceleration times time, t1 in this case. Our initial velocity is going to be 0 because we start from rest. And solving this for time, then we have that t1 is equal to our final velocity divided by acceleration, 20 divided by 2, or 10 seconds. So this first leg of the journey is 10 seconds, this leg right here, and so that will stop at 10 right there. Sounds good. So first question is, how long is the truck in motion? Well, the total time is going to equal the time for the first leg plus the second leg plus the third leg. And in this case, that is going to be 20 seconds for the second leg and 5 seconds for the last leg. So the truck is in motion for 35 seconds. Sounds good. Alright, part B. How far did the truck travel? Well, if we look at that first leg, we would have that our displacement in the first leg is our initial velocity plus our final velocity divided by 2, average velocity, times our time in that first leg. That is going to be 0 plus 20 over 2 times 10 seconds. 10 times 10 is 100 meters. We can only deal with each leg by itself because we need points of constant acceleration, and at the interval, at the boundaries to these intervals, the acceleration changes abruptly. So we can only look at each interval separately, and that's what we need to do here. So if we look at the second leg, what do we know about that? Well, we know that our initial velocity is 20 meters per second. We know we have constant velocity, so our final velocity is also 20. Our acceleration is 0, and our time is 20 seconds. And we want to find displacement. We know displacement should equal initial velocity plus final velocity divided by 2 times our time. That means our displacement, delta x2, is going to equal 20 plus 20 divided by 2 times 20, which is going to be 400 meters. So that'll be our displacement in the second leg. What about the third leg? What do we know about that? Our initial velocity is 20. Our final velocity is 0 because we came to rest. We slowed down over a time of 5 seconds. And we want to find our displacement. We don't know our acceleration. We don't know our displacement. But we have 3 kinematic variables given and a fourth one asked for. So based on that, our displacement will equal our initial velocity plus final velocity divided by 2 average velocity times time. And this will be 20 plus 0 over 2 times 5 seconds, which is going to be 50 meters. So our total displacement for this whole leg is displacement 1 plus displacement 2 plus displacement 3. Which is going to be 100 plus 400 plus 50, 550 meters. Try to fit everything on this page. So, how far did the truck travel? 550 meters. How much time did it take? 35 seconds. Average velocity is our total displacement over our total time. And the only way we can do it in this case, we can't really average each leg because they're over different time intervals, but we can take our total displacement over our total time and get an average velocity for the whole trip. So our average velocity is our total displacement over our total time, and that is going to be 550 meters over 35 seconds, and that is equal to 15.7 meters per second. So that's our answer for that. So we got all of our answers for A, B, and C. Here's just a little extra stuff on this. If we have a velocity versus time, the slope of our velocity versus time graphs is indeed our acceleration. So in the first graph where we went up 20 over 10 seconds, our acceleration was a slope of 2. And then our acceleration for the middle section was 0 because we had a flat line. And then our acceleration in the last section where we went down 20 over 5 seconds is a negative 4. So the slope of that graph is acceleration. The integration of velocity versus time is indeed displacement. So in other words, we find our total displacement by integrating over this graph. And in other words, anytime you integrate, you're taking the area underneath the graph. So the area in this triangle right here, this first triangle, is really going to be 1/2 the base times the height. 1/2 times 10 times 20 is 100. So there's 100 meters in that first leg. The area in this second leg is 20 times 20, which is 400 meters. And the area in this third leg is going to be 1/2 the base times the height. 1/2 times 5 times 20 is going to be 50. So we have 100 times 400 plus 50, or 100 plus 400 plus 50, 550 meters. That's the area underneath the graph, and that is our total displacement for this whole trip. So that's the answer to problem number 2.